Boom. Hello and welcome back to Precalculus 1, section 7.4, Systems of Nonlinear Equations. So, we've seen systems of linear equations with 2 variables, 3 variables, number of equations. We know we have substitution method, elimination method, and so on. Nonlinear equation is the equation that would have a square on y, or it would have some weird stuff happening that you really can't write it as y equals everything else, which is plus you also have a quadratic function, so y equal x squared, right? Parabola, that's not linear, straight line. You have a circle, an ellipse, and all of these kind of things that you did study in algebra, and you will again study at the beginning of PreCalc 2 if you take PreCalc 2. So a linear equation is equation that is x is the first power, y is the first power, and like y equal mx plus b or ax plus by equals c. Those are linear equations. And then you will say linear equation for 3D would be a plane, which is, again, we talked about it last class. It was a flat surface like a ceiling or a floor or a wall, surface of the desk. And the plane, again, would have x, y, and z values all to the first power. As soon as you include a square or a square root or on x or y, or you do some combinations like x times y, any one of that stuff, including exponential, including trig, including all of these kind of things, it becomes nonlinear. So as soon as that straight line or the plane becomes any type of a curve, it immediately stops being linear and becomes non-linear. Now, we don't have a form for a non-linear equation because it is just so broad. We say x and y to the first power. If you have equation with those, that's linear. And if you have anything else but that, it will introduce curvature, and it's all immediately nonlinear. So an example of a nonlinear system would be x squared equals 2y plus 10, and 3x minus y equals to 9. So the only thing that makes this system nonlinear is the x squared term. Everything else about this system is linear. The second equation is linear, but because the first equation is nonlinear, the entire system is nonlinear. So we have that part. So now, how do we solve these systems? Well, it's going to be elimination or substitution, whatever works better. And you decide that by working out 5,000 problems. So what I would do in this case is I would solve for y in this equation. So move y to the right, and then move 9 to the other side, and then swap the sides. So I did 2 steps in one here. I first moved y to the right, became positive y, and then moved to the 9 to the left, became negative 9. And then I just swapped the sides. And now I take this and I plot y. All right, it might be. Okay, I think we're good now. So we have x squared equals to 2. So this equation that I have is the same as the first equation, except that y is replaced. So this is just a standard substitution, guys. Nothing crazy. Distribute everything and solve the quadratic equation. You will get your x's. So x equals 6x minus 18 plus 10. X squared equals 6x minus 8. Move everything to the left, which is x squared minus 6x plus 8 equals to 0. This is the standard way to solve quadratic from algebra. And now, whatever works. Factoring, quadratic formula, black magic, I don't know. Whatever you know for this. Can we factor? Sure, in this case was easy. X minus 2x minus 4. Again, if you don't know how to factor, you have choice of going back and relearning it, or you can use the formula. Negative b plus minus b squared minus 4ac over 2a to get the same values of x equals 2 and x equals 4 as you set each one of these to 0. So we have, so this is what we have. Now, am I done? No. I obtained x values, I need y values. So what are the y values? Where the y values are, you have the y equation. Y equals 3x minus 9, I believe. Yep. So now you plug in 2. So that's 3 times 2 minus 9, which is negative 3, which gives us the first point of 2, negative 3. And when you plug in 4, that's 3 times 4 minus 9, which is 12 minus 1, is positive 3. So we have x is 4, come on, x is 4, and y is 3. So this is what we have for our problem. I'm not sure if this thing is working because maybe it's working, I don't know. I have this red thing over here, so take notes. We're done. What does this mean? This means that the two lines that you had intersected at these points, creating these solutions. That's what it means. So you have some kind of parabola intersecting with some kind of linear line. So I'm just going to draw a sketch of this. So this is what it might look like. And then you have one solution. Well, actually, I'm just going to ignore the, is this a positive or negative slope? Positive slope, good. So this is what you have. You have a quadratic equation, which you can solve, right? Y equal 1/2 x squared minus 5 or plus 5, whatever it was. And you have the linear line. So these 2 points, this point here would be 2, negative 3, and this point here would be 4, 3. So this is the meaning of the whole thing. Without graphing it precisely, the graph will look something like this if you graph it. So you can approximate the number of solutions before you solve it, because you graph one function. If you are intersecting parabola and the linear line, right, you can play this game at home of what would you get if you intersect different lines together. So if you intersect parabola with a line, you can get 2 solutions, you can get 1 solution, and you can get no solution, right? So you can get, these are the only possibilities to intersect a line with the quadratic, with the parabola, and these are the only situations that could arise. Now, you can't really come up with some kind of formula and stuff for this. It's just the shape. You see, I can have a basic cubic that looks like this, and then intersect with a linear line and have 1 solution, or I can have a cubic that goes like this and intersect with the linear line and get 3 solutions, or intersect and get 2 solutions. You see that? Any intersection between 2 functions or non-functions, circle is not a function, would give you number of solutions. So you can guess before you go on calculating the number of solutions that you might have. Or you can say, at most, I have 3 solutions, and so on. You see, you can intersect a circle with a line, a circle with a line at one point, and a circle at the outside, right? So 2 solutions, 1 solution, and no solution. But then circle intersected with parabola, 4 solutions, right? I can make it into 3 solutions. They touch here, there, and there, right? So you can have any of these combinations. No solution, a circle, and then a parabola goes around, right, like that. Or circle is on this side, it doesn't matter. So they have to be somewhere on the xy plane, you can graph them, and then it will fall into one of these. Now the type of the equation will tell you what you are working on. Like what type of functions or curves you're working with. So y equal x squared plus 3, and x squared plus y squared equals to 9. So this is definitely parabola, right? It has x squared in it. And what's the one on the bottom? Yes. Circle. Radius 3. So you have the situation that you see above. You can have 4 solutions, 3 solutions, 2 solutions, 1 solution, or no solution. You have 5 different things. And it all depends on which way these things are going to work out when you solve these equations. Now the way we solve is substitution method or elimination method, whatever you like. You can move x squared to the left, becomes negative x squared plus y equals to 3, and x squared plus y squared equals to 9. You add equations, it's a simple elimination method, addition method. X's will die, and you have y squared plus y equals to 12. Right, 3 plus 9 is 12. You can't add these. I know you are used to adding those, but now they're not like terms. One is y squared. So they can't be added. So that's why we list them both on the pile, and then equals to 12, 3 plus 9, right, it's 12. Now you subtract 12 both sides, so y squared plus y minus 12 equal to 0. Factor it. So we need plus 4 and minus 3 to get your negative 12. They have to be opposite signs, and then they add to positive 1, so 4 minus 3 is positive 1. So we got our y equals negative 4 and y equals to 3. Again, if you don't know how to factor, use the quadratic formula, and you'll be fine. Note that I do not have equation for x, right? So I have to plug this in into any of the previous equations and work it out. So let's go with y equal x squared plus 3, from where x squared is equal to y minus 3. And now if your y is negative 4, x squared equals to negative 4 minus 3. You get x squared is negative 7. X equals square root, positive negative square root of negative 7. That's not real. Not real. Therefore, we do not have x values for y's. So no x values. And if we solve the other one, which is x squared is equal to 3 minus 3, right, when y is 3 for the second one, we get x squared equals to 0, you get x equals 0. So now you get a point 0, 3. It intersects at only one point. So what kind of x plus d1? So this graph looks, let's say, something like that, intersects at one point only. I mean, circle could be on the other side. Without me going to graph this exactly, circle is somewhere. So it's one or the other, but it's touching at the one. And this point here is 0, 3 on the y-axis. Now you can go and graph it exactly and see what it is. So it's trickier. It's trickier than what you're used to, but definitely doable. So x plus 2y equal to 0, and then x minus 1 squared plus y minus 1 squared is equal to 5. What is the equation on the bottom? It's a circle. It's a circle that is shifted. The center of this circle is at what? Where is the center of the circle? 1, 1. Very good. And the radius is root 5. Yeah, good thing we don't have to use it, but it's root 5. So how do we solve this problem? Well, you solve first equation for x, which is negative 2y, and then you plug in into second equation. So instead of x, I have to write negative 2y, and then minus 1 everything squared, plus y minus 1 everything squared equals to 5. Now, square all of this. So that's 4y squared minus plus 4y, and then plus 1 plus y squared minus 2y plus 1 equals to 5. So the first three terms are the square of the first one, the second three terms are the squares of the second one. Combine like terms where I get 5y squared minus 2y, plus 2y, and then move the 5 to the left, so you have 2 minus 5, that's negative 3. We get 0. And now you either factor or you unleash quadratic equation. So let's use quadratic equation here. Negative b, so negative 2 plus minus square root of b squared, which is 4, minus 4ac. So that's 20, 60, 60, divided by 2a is 10. So this is negative 2, square root of 64 is, very good, divided by 10. So one solution is going to be 6 over 10, which is 3/5, and the second solution is negative 10 over 10, which is negative 1. So I have y equals 3/5 and y equals negative 1. we have our substitution equation x equals negative 2y. So x equals negative 2 times 3/5, which is negative 6/5, which creates the point 3/5. No, have to list x first. Negative 6/5, 3/5, and then you have x equals negative 2 times negative 1, which is positive 2, so the second point is 2, negative 1. So the circle and the line intersected at these 2 points. Now I could graph this and see. It's just that the square root of 5 as a radius is not a greatest value, because that's about 2.23, and to graph that would be somewhat, right? So, I mean, we can do it. If this is my center, I go 2 units and a little bit, and then 2 units and a little bit, and then 2 units a little bit, 2 units a little bit. So there we go. That's a negative 1, 1, negative 1, negative 1, right? Or we had 1, 1. What was it? Well, it was 1, 1. That was 1, 1. So if that's 1, 1, then your x and y axis have to be 1 unit away. And then you also have equation that is x equals 2y, sorry, minus 2y, from where y is equal to negative 1/2 x. Well, negative 1, so drop 1, run 2, and a 0, and then connect them. I actually did a pretty good job here, because you can see the 2, negative 1 point. You see how it did fall right, the intersection fell right in where it should be. And the second one works as well. In a second, this thing is spazzing. This point here, the second intersection of the line and the circle, is the negative 6/5, positive 3/5. So negative 6/5 is 0.2 behind negative 1 to the left, and then 3/5 is about 0.4 in. So that's the second point. So that point there is negative 6/5, 3/5. So if you want to solve it as a graph, you can, but you will be really disadvantaged as you try to read points that are not perfectly lined up with the grid that you're used to. It is a wonderful problem for you to work on. 3x squared plus 2, yeah, I know, equals to 35. Yeah, I know how much you love this stuff, so, you know, I don't want to disappoint. There we go. This one? Yeah, it's a 3 with an age. Because without age, it's just a tree. No, true is spelled with. You can also tell that I took the wrong column. Is it? It didn't help. No. I went to this last show. So
March, did shows in March in New York, and then he died in New York. All the light bulbs that I hold to. I started using a word on humans came up with it. And then I had to find it because everyone thought that I just saw it in the movie and kind of killed it. I used to work at a restaurant as a food runner / manager in order to know so in the training of all the incoming buses who were all high school kids was under my jurisdiction and I had more than that. So all the trains were done by the was respectable. We had very important and I worked there. So I did work several at the end of the building every time I had the first and I used to live right across the street, first house. So this one time I got this and all the servers were so I get some buses and just so Sarah would say I need something and so I said, all right, and then one person wasn't explored, was the other one wanted to bring more chemicals. So we exited the restaurant, I got to walk around and walking as we are walking. I multiply the top by everything you see inside. Do not speak on the outside of this environment. Approach the pages. Yeah, they offer you.
No, but I don't want.
Yeah, there is the same one as that. Then they open it just a small. So it's I guess some of the first ones that's the road. Across the street. And all of the servers go behind the phone that whoever is has to drive you home because he doesn't have a car. He's the one. He has no car, so the whole night they would try to get out there and then she finally got the courage to ask me. So I have to this down so walking around and I sit inside and put the seat belt and she's like, what? This one doesn't have so where do you live? And I go, stop! No, 1 second. I said, stop. And she goes, whoa. I said, this way. She came back next day. She was crazy. Why am I trying to go to hospital? It was so crazy that I ended up head waiter, bartender, and a busser were chasing me down the street in the back seat. There was something to see. Imagine if you were coming rushing to the cinema. A guy with a white shirt and a tie and black pants running out, and you have the server, bartender, and a busser. They running out.
I haven't been there 5 years.
All right, so standard elimination works here. We are going to multiply the top equation by -3, say, and the bottom equation by +2 to eliminate y's. If you're eliminating x's, you have to multiply by 3 and 4, which creates larger numbers. And we don't want that. So -9x squared minus 6y squared equals to -105. Generally, you forget to multiply these numbers, so pay attention there. Right? And then 8x squared plus 6y squared is equal to positive 96. You add two equations, which will eliminate y, so you have negative x squared equals to, the difference of this is -9. Which means that x squared is equal to 9, from where x is equal to what? No. Plus or minus 3. So when you square root this, I'm going to write that step in. Square root of x squared is equal to plus minus square root of 9. When you are square rooting both sides, you must put plus 9. So plus minus 9. So you guys are getting x equals 3 and x equals -3. Two solutions. Now you are going to bring 3 into any equation. So we can use the first one. 3x squared plus 2y squared is equal to 35. And you plug in x equals to 3, so you will get 3 times 3 squared plus 2y squared equals to 35. 3 times 9 is 27. So 27 plus 2y squared is equal to 35. Minus 27 on both sides. 2y squared is equal to... Very good. And then divide both sides by 2. Y squared is equal to... Perfect. And then what's y? Plus minus 2. So what we discovered is that input x equals 3 gives us two outputs. One y equals to 2 and the other output y equals to -2. So you have 2 points here. 3, 2, and 3, -2. Now you will go and do the same thing, but this time for -3. So 3 times -3 squared plus 2y squared equals 35. But -3 squared is 9, and then this is 27. Plus 2y squared equals 35. You see this is the same, right? Which will give you the same y equals plus minus 2. But now you started with -3, so it's -3, 2, and -3, -2. 4 points.
Can you explain why you created this second version again?
second.
Like, why do you do
Oh, well, we have a 3 and a negative 3. We came up with 2. So I used the 3 first time around, and then I used negative 3 the second time around.
Oh, so that's what it is.
So, but if you look up, this equation and this equation ended up being the same because negative 3 squared and 3 squared are both giving you 9. So we were just lucky to get the same equation, which in turns gives us the same answers. But the input text is different. So you have 4 distinct points. What were we intersecting? We were intersecting 2 ellipses in this case. You don't know that these are ellipses because you haven't covered that yet. That's the beginning of your Precalc 2 class. So what you are essentially intersecting is the ellipse or the oval that goes that way and the one that goes this way, and you are experiencing 4 intersection points that are the 4 points that you found. Now the graph of this again is going to be in your Precalculus2 class, unless they actually included it here. They did not because you did not cover it. So yeah. Look at your homework. Look at that. Like, this is I think this is the most beautiful chunk of the book. You should copy this and laminate and put on a small thing so everyone's asking, hey, how are you doing? What are you up to? Look at this. Instant headache. So this is what the homework looks like. You have a whole bunch of these equations, and it's just practice, practice, practice. It's substitution, it's elimination. We are not learning any new concepts. Now you have to be careful because you have quadratic equations all over the place, which produces 2 solutions. So you have to be careful about this plus-minus business that creates extra solutions. And then you just plow through. These first few problems are extremely easy dealing with substitution because, look, you solve x is, let's do 10, because we can. Let's do a few from homework, and if you have no questions, we're done. So problem 10, all that excitement. xy equals negative 12. And x minus 2y plus 14 equals 0. So this is problem 10. So xy equals negative 12, x minus 2y plus 14 equal to 0. Okay, there we go. So try this one on your own.
Yes. This guy's good in person agree.
So, which one we solve? What do you do? Exactly. X equals 2y minus 14, and then plug up. So, we have 2y minus 14 instead of x times y equals to 12. So that's our equation 1, where x is replaced by 2y minus 14. Distribute to get 2y squared minus 14y minus 12 equal to 0. Divide the entire equation by 2, because all of the numbers are divisible by 2. Obtain y squared minus 7y minus 6 equals 0, which you can easily factor. So y minus, you can't easily factor, right? Is this good?
Wait, I have a question though.
Yes.
Shouldn't you start doing it by doing y equals and then like put like the negative 12 over x?
Oh, it's negative 12 on this side. That solved my issues. Thank you. Yes, there are many ways you can do this. Yes, so you can. So yes, you can. Now you can easily factor this. So this is y minus 6y minus 1 equals to 0. Y is 6. Y is 1. So now we have the equation x equals 2y minus 14. X equals 2 times 6 minus 14, which is negative 2. And 2 times 1 minus 14, which is negative 12. So 2 points. Negative 2, 6. Make sure you list x first. And the second point, negative 12, 1. So we have 2 solutions. And there will be 2 intersection points between these functions. Now, what type of functions are these? This is 1 over x, which graphs this way, and then a linear line, which, let's say, goes like this, whatever. What is it? Yeah, it's a positive slope, so something like this, right? That's what we have. And you see intersection 1, intersection 2. So 2 intersection points. Again, I'm not graphing this exactly, so this might be a little bit different, but in general, when you graph functions of type a number over x, which is what you have, you will always get something that looks like this. And when you graph a linear line, you will always get something like that. Now, if this line is here or there, or, you know, I don't know where the line actually is, because I'm not graphing, I'm just sketching. So, yeah, that's what we get. Another one? Yes? Most likely not, because you have a few sections on graphing from chapter 1, right? So this is more for those students that would be going into calculus later on. These types of analysis of graphs is very important, so you can skip a whole bunch of calculations rather than, you know, cranking through every single thing. Graphs are very useful, but again, when I pull the classroom, majority of you are not going for engineering, so we are not, or actually none of you present here are going for engineering. Maybe some of the people who are missing today, but yeah. All right, yes.
I didn't get it, so I just want to make sure I put the same.
And was it the same?
Partially, I made it work.
Oh,
Yeah, I was on the right path. I just forgot the Y
just
square.
made a wrong turn.
I made the wrong one. I got
Right.
one Y instead of two Y's.
One more problem and call it a day. I said few problems. Listen to the stream. And few is goes up to 3. So I have a cushion of one more after this. But then looking at faces of some of you, it's free money, I mean. Ooh, you're gonna love this one. Now I'm going to give you, I'm gonna put a timer on. You have 2 minutes. Timer on, challenge on. 31. And it says 2x squared plus y squared equal 18. 2x squared plus y squared equals 18. Second equation, xy equals 4. Go. One minute left. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, done. All right. What do we do? Anyone? Well, we solve for either x or y, whatever. Let's say y equals 4 over x, and we plug in. So 2x squared plus, and now you have 4 over x squared equals 18. So this is one of the ways to solve it. So that's going to be 2x squared plus 16 over x squared equals to 18. And if you can immediately see that everything is divisible by 2, you get x squared plus 8 over x squared equals to 9. And now you multiply by x squared. The whole thing times x squared to cancel denominator. So you have x to the 4th plus 8 is equal to 9x squared, which is x to the 4th minus 9x squared plus 8 equal to 0. And just use the standard intermediate algebra trick. U equals x squared. You've seen this also in your exponential equation solutions, the substitution method. So you get u squared minus 9u plus 8 equals 0. That factors into u minus 8, u minus 1. And you get u equals to 8 and u equals to 1. Now, no one cares about u. Care about x, right? So, we replace each u by x squared. And then take square roots of both sides. So, x equals to plus minus 2 root 2. Square root of 8 is 2 root 2. And x equals plus minus 1. We have 4 x values. 4. All right, so I have x equals 2 root 2, x equals negative 2 root 2, x equals 1, and x equals negative 1. And we also have equation, substitution equation, y equals 4 over x. So now, y equals 4 over 2 root 2, y equals 4 over negative 2 root 2, y equals 4 over 1, and y equals 4 over negative 1. 2 and 4 will cancel. Get 2 on top. Then you rationalize. And we get that y is equal to 2 root 2 over 2. And then 2's cancel. So you are left with root 2. The second one will work the same way, except it's negative root 2, right? Same numbers. 4 divided by 1 is 4, and 4 divided by negative 1 is negative 4. So what are the points? 2 root 2 root 2, negative 2 root 2 root 2, 1, 4, and negative 1, negative 4. For solution. What? All right, I'm done. That was his comment. All right, I'm done. I guess you're done. All the homework is open. Please remember that. You can log on to any of the sections and fill in the blanks, and also practice for final exams coming up. Look for that file, guys. Look for that file where the syllabus is. That file should help you prepare for the final. And I will see you all on Tuesday.